Okay, so now let's talk about some inscribed angles and their properties. Remember that an inscribed angle is formed by two chords whose vertex is on the circle itself. So if you look at our diagram here, you'll see we've got angle A, B, C, and this angle B here is actually on the circle. So angle ABC is the inscribed angle, and then arc AC is the intercepted arc. And remember, the intercepted arc simply means that it's the endpoints, if you will, of that angle where it touches the circle. So now let's look at a few properties. So if we look at Explore number 1, our theorem states that the measure of an inscribed angle is half of its intercepted arc. So let's try example 1 together. If you look at what's given, you know that the measure of angle X, Y, Z is 55 degrees. So let's make a note here at the vertex, 55 degrees. And then I know also that the measure of this arc AC, given my theorem, should be double that inscribed angle. So if my angle XYZ is 55, then this arc XZ is what it should say actually on that worksheet. XZ should be the 110. Okay, so we would put 110 here. Degrees. So again, this should actually say the measure of XZ. If we have the angle at 55, then the arc will be 110 degrees. So now let's try a few more examples. If we look at this first one here, example A, we're given that the measure of arc CT is 130 degrees. So this time we're given the arc here at 130. And then we know that the measure of angle CAT must be half of that measure, so then the angle will be 65 degrees. We just take 130, divide it in 2. Now let's look at example B. I'm given that the measure of angle DOG equals 15 degrees, so DOG is 15. Therefore, the measure of my arc DG must be, you got it, 30 degrees. Now let's look at another property with inscribed angles. We're given a diagram here, and after we explore some pieces of this diagram and answer these questions, then we'll discuss the theorem stated below. So first off, what type of angle is angle XYZ? From X to Y to Z, you should recognize that that is an inscribed angle. If we look at the next question, what is its intercepted arc? So again, from X, Y, Z, we should see that the intercepted arc should be from X to Z. So arc X, Z. Don't forget your notation here. Now what type of angle is angle XAZ? So from X, AZ, again, that vertex is on the circle, so we've got another inscribed angle. And then what is its intercepted arc? Well, look again, we've got this arc XZ. So for some conjectures that we could make with this property, answering these questions here, we see our theorem emerge. If two inscribed angles of a circle intercept the same arc, then those angles are congruent. So we did see that they intercepted the same arc here above, therefore angles XYZ and angle XAZ would be congruent. Let's look at a third property here. We see that we're given a few questions and then we'll discuss the theorem below. So, what is segment AC? So if you look at segment AC on your diagram here, you'll notice that the endpoints lie on the circle and it does go through the center of the circle. So by definition, this is a diameter. What type of angle is angle ABC? Well, the vertex is on the circle. So vocabulary, it is an inscribed angle. What is its intercepted arc? You'll notice the endpoints here. We have A, C, so the intercepted arc is arc AC. And you'll also notice that AC, since it's the diameter, then that intercepted arc would be a semicircle. And we know that the semicircle is 180 degrees. Therefore, that inscribed angle, ABC, for this next question must be 90 degrees because that inscribed angle is half the measure of its arc. So measure of angle ABC is 90 degrees, and I'll go ahead and notate that here. So my theorem states that an inscribed angle is 90 degrees if its intercepted arc is a semicircle, meaning that the endpoints are on that diameter. Let's continue on. We've got one more theorem here. Our last one states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. A few things to note here. We've got inscribed, so the prefix in means that it is inside. And then we know also supplementary is 180 degrees. So if we look at angles 1 and 2 of our quadrilateral, then the measure of angle 1 plus the measure of angle 2 would be supplementary. They are opposite, so 180 degrees. Let's try the few below. A circle can be circumscribed about which of the following? So let's look at this first one here. We see we've got 110 and 70 as opposite. Those sum to 180. Then we have 95 and 85, which also are opposite and sum to 180. So yes, that is possible for our first diagram. If we look at our second diagram, we see we've got an isosceles triangle as trapezoid, as indicated by the congruent tick marks here, and one set of parallel sides, opposite sides. If you recall from your isosceles trapezoid properties, you'll notice that our base angles would be congruent for each base. And with that, then the opposite angles would have to be supplementary. Again, with these two parallel lines here, we've got same side angles would be supplementary, so here and here. And in that case, then the opposite angles would be supplementary as well. So for this example, yes, that is true. And now our last example, we've got a parallelogram as given by two pairs of opposite sides parallel. And we do notice that our opposite angles here are congruent rather than supplementary. So in this last example, the answer is no. For this last set of examples here, you try these on your own. You've got B through G, a few questions to answer using this diagram here on the right. Please bring these in answered along with these notes for your next class period. Have a great day.